Hi guys, morning. Morning, Kieran.
Morning.
You sound really enthusiastic, mate.
Oh, it's a Friday.
Is it? No, it's not Friday, is it? It's a Friday! Lunatic. So Kieran, what are we doing today? Yes, that's right, I know.
Doing a EICR.
So we're doing the EICR today. This is a property. I'll chat to Kieran in a minute. Get his information. We have 3 consumer units, all the old rewirables and a mixture of the newer 60898s. You've got the main DB, you've got storage heating, emergency heater, and this is all going to be, I think these are on economy 7 off peak supply, so need to check that out. It's the first time I've seen it apart from coming to do the quote the other day. So as you can see, nothing's labelled up as always. There's no thing there. Yeah, nothing's labelled up, so we need to find out what's what in there. But before we start, so we're using the Electroform. I don't know anything about the installation, what it's like. So we're doing an EICR. Kieran, what is an EICR?
Electrical installation condition report. There you go.
Thumbs up, well done. So what's the purpose of an EICR?
To test the condition of the circuits in the building to make sure they're fit for further use.
You can't say anything wrong with that, can you? And what is the reason we are doing the EICR with regard to them circuits, and we'll speak about why we're here today.
We're here to do an EICR because next time we come here we're going to replace the consumer unit, and we want to test to make sure that all the circuits are fit for use with the new consumer unit, because the older ones can't pick up as many faults as the newer ones can because they're not as sensitive.
I haven't just fed this. We discussed this job yesterday, and I said why are we doing it, all that, and it's so top job, mate. Well done. You've done the EICR before, haven't you?
No, I have not. We did we did actually.
We did,
but it wasn't just the EICR we were there for. Yeah, I remember that.
Yeah.
So
Okay.
we had an issue with the loop not being connected in that kitchen.
Okay. Yeah. So yeah, the EICR we done before found a loop, a ring. I said loop. I get into his territory. Found a ring final circuit which wasn't a complete circuit. The ring, I can't even talk today. The ring wasn't a complete ring, it was a broken ring, and we don't like a broken ring, do we, Kieran?
No.
Right, so first thing we will do is whip the cover off, and then we need to do functionality. Actually, I'll tell you what we'll do. We'll do functionality and test what the circuits are first. Okay, first thing we're going to do is we're going to do a walk around check. Make sure everything's working before we touch anything. Unplug the sockets because we need to do installation resistance testing on it, and checking for any cracks visually on anything like that. So start unplugging some of these things, checking what some of these lights do. Don't know what that does. Undercounter lights. Yeah. Eventually. Using socket tester. These are not to be relied on, I know, so don't shoot me down, but it is a very good indication of the problems that you can get. And then we can go for there. We do complete full testing as required. Actually, for an EICR, you don't have to complete full testing. Did you know that?
No.
Yes, you do. You don't.
What do you mean by that? Do you do full testing?
I don't know. No. If you've got, so I've been told this before, if you've got an existing installation certificate or a previous EICR certificate, you don't have to complete full testing. What you can do is ZS's and RCD checks around the house. And I was told that on my 7371 course, which was a few months ago, but I wouldn't do that anyway. I'd still go through the full test procedure because you don't know if anything's been added since that certificate's been made. So It's a cooker circuit. Okay. It's not working. Okay. So there you go, that's not working. That wasn't working before. I suspect that's what that socket's for. There. Okay. Go around. We'll have a notebook with all our observations on it. What's this here? 2.3 kilowatts. Right, it's working. Don't know where the isolator for that is. Sometimes I bung them in cupboards. Can't see anything. Right, I can't see anything for that. Light's working. That's working. Don't know what these two lights do. And we'll go around the house.
Are they outside ones?
I don't, yeah, possibly actually. Yeah. What we'll do, we'll go around the house in a clockwise direction. Make sure what's in here. We're not being nosy, we have to do this as part of our testing. So storage heater, not storage heater, immersion heater, both switched off. That's the elements for heating in there and there, but they're both switched off. So don't know why they're switched off, but we'll still test it. Living room, lighting working, just one light out. Storage heater there. Got a supply on the right hand side, looks fairly new. Okay, they're not coming on. Let me just go and make sure that they're switched on. The customer could have switched them all off. Doesn't seem to be a supply coming through there. Okay, so that is more than likely then. Oh, sorry. That's more than likely on an off-peak supply, which I'm sure we have here. Can't get access to the sockets around the back there if there are any. So again, we need to be aware when we're testing that we don't do a test at 500 volts DC. Socket down here. Light, this has two-way lighting and light out here. Don't know what that's for. Unknown. Again, I'm not being nosy, I'm just making sure there's no electrical bits in there that we need to know about. Okay, that's that. On the face of it, it doesn't look very big. Okay, in here we have, I think it's another storage here. This is not good, putting things like that, flammable thing on top of a hot thing. So I'm going to move that, I don't like that. I will tell the customer, not a good idea. Put it near it, yeah, but not on top. Okay, if we look at this here, can you see that? You might not be able to see it, but you can see basic insulation. Can you remember what I said about basic insulation before, Kieran?
You're going to have to remind me.
It's fine. You shouldn't be able to touch basic insulation. I can touch that. So that goes down as observation. So this is your guidance note 3, essential if you're completing EICR or any testing. Really good book to have. If you haven't got one already, you must get it. Another good one to get is Electrician's Guide to Building Regulations. Really good bit of book. So when we're completing EICRs, there are different observations that can be made. So let's go through the observations. So C1, it means danger present, risk of injury, immediate remedial action required. So if you've got a socket that's fallen off and you can touch the insides of the back of the socket, you need, that's classed as a C1 because you can touch live parts. C2, potentially dangerous, urgent remedial action required. Okay, in that case, that could be like what we've just seen there. You can touch the basic installation, so it's not immediately dangerous, but if it was just to have a little nick in it, then you know you can get injured. What it means is it needs something to happen before it becomes dangerous. So that's the difference between C1 and C2. C3, it means improvement required. It says there. I'd say recommended, but that is things like non-compliance, for example, plastic consumer unit, things that were good in the past which are not good now, but not necessarily dangerous. So you'd recommend getting them changed, but you don't have to, and you can call that C3. Further investigation required. That's, for example, as we saw in a previous job where we had a break in the ring circuit. We need to find where that break is and fix it before we can go any further, or before we can get a satisfactory certificate or potentially change the consumer unit. So that's the different codes we can have for EICR. Okay, so let's carry on with our walk around check. Lighting working. You can see this light, it can be quite common. The ceiling rose is going to be probably behind that, so we get no access to test that. It's going to be awkward if they have faults in the future, but it is an attic above, so you can get around it. Sockets in here. Blanked off socket as well. Looks like that was a heater at some point. Socket here. Yeah, good. Just move these out so we can get access. So if we remember to reset that alarm clock. Yeah, all good. Good. And into the living room. Don't know where that is. That's that. That's that. Oh, is that the bathroom?
No.
No. Okay. Okay. I've seen something here. What do you think about this, Kieran?
Oh wow, hello.
What do you think about that?
Is that connected to anything?
Yeah, it's connected to this lamp. What do you think about that?
That's just dangerous.
So what observation would you give that? Compared to what we've just spoken about?
Oh, I'm trying to remember them now. Would you say C2? Because it's not like immediately dangerous, only dangerous if someone plugs it in. But it is something you shouldn't have laying around. That's
a good point. It's not dangerous. Like, I can touch that.
Yeah.
It's got a good point. I can touch that. It's not dangerous. So potentially that's a C2 because it needs to be plugged in. But the thing about EICRs is it's a test of the fixed installation. This is not part of the fixed installation. This is a mobile pat testing equipment, if you like. What we'll do though is I'll just put a lid on just in case the lady was to want to plug it in. I haven't tested it and that's not part of my test. Also, something to note, nothing to do with EICR, it's to do with pat testing. These are the old plugs where you don't have the sleeving on the bottom bit there, on the live pins. On the new ones you have sleeving so you can't put your finger in when you plug it in, but these don't have them. Again, I won't even put it on the list because it's not part of the EICR. But yeah, good discussion that. Checking for any sockets. Socket here. And rewired at some point. Careful. Okay, so all good. Wow, look at this. Kieran, a little bit of history for you. What is that? What model of airplane is that?
Is that the
Very, very famous airplane. Helps during the Falklands conflict.
I can't remember.
It's called a Vulcan. Massive wing, and they're really loud. Going over it. They used to fly them over Northampton sometimes. Recently, really famous aircraft. Wow. I don't usually pick up random customers' bits and pieces, but that's a really interesting piece of what do you call it there? Right into the bathroom. Okay, pool called. Shower isolator. Just make sure the shower's working. Yeah, it's working. One thing that I don't like to see is a shower without an RCD. I would never use a shower without an RCD. Strictly speaking, it would be a C3 because at some point it did comply, but with each installation you test for the installation. I would always recommend putting very minimum, I would say put that on an RCD because you're getting yourself into a shower with conducting equipment. If anything was to go wrong, you're dead. It's easy as that. So I always put that as a C2. Wrongly or rightly, but I've got my reason. I've just said what my reasons are. Right. This is interesting, Kieran. Light fittings. These are down lights. Let's check what type of IP rating these need to be. Okay, so that's 18 centimeters outside of the zone of the edge of the shower. You can see that. So that's there. 18 centimeters. Let's check something else. It is 238 centimeters above the floor. So strictly speaking, again, that's outside the zones. But being a shower head, so it's not fixed, I would like to see IPX5 on them light fittings, and I'll put that on my report. This is slightly higher level here, so let's check the height here. If it's over 2.25 meters, then it's outside the zones. This is 222, so actually that is inside zone 1. That's inside zone 1. That's inside zone 2. So it needs to be minimum IPX5 rating, which is not. So these need to be changed. So 1, 2, 3. Down lights changed. That's that. Nothing else electrical in here. Ah, we've got a shaver socket. What's the minimum distance from a socket from the shower?
Oh, you've told me this. I cannot remember.
So it was 3 meters, but in Amendment 2 it's now 2.25 metres. No, it's not 2.25, but in Amendment 2 it is 2.5 metres. This is a different type of socket. This is a shaver socket, which is, and I can never remember what the exact word, something like centre pin, transformer. I can't remember. It's just gone from my head. But you can have these in the bathroom. It's fine. We've got an electric towel rail here with a fuse connection unit underneath it. Okay, that's on at the moment. So that's okay. I'm happy with that. We just need to test, make sure the earth is okay on it. And that's it really, not really that much in it. Now what we'll do is we'll go around the house and make sure what circuits everything is on. I don't know if you can see this, Kieran, but if you look at this consumer unit, can you see anything wrong?
There's a massive gap in the middle. And there's also a massive burn mark.
And a burn mark, good to point that. So what code would you give that?
I do not know for that.
So C3 is the least dangerous, C1 is immediately dangerous. What code?
I'd say C1 only because you could put your finger in there and electrocute yourself.
Yeah. So the front of an enclosure needs to be a minimum of IP2X. IP2X, I can't remember exactly what the description of IP2X, I can't be bothered looking that up right now, but yeah, it needs to be a minimum IP2X. You can easily get your finger in there, so that's access to live parts. And what code is it, Kieran?
Oh, C1.
C1. Yep, that'll do for me, that's good. Another observation, it's not labelled up, so what code will you give that?
Will that be a C3 because it's not like the end of the world, but
yeah,
it does. It's something you should really do.
I'm going to suggest that to the IET. C3 should be called not the end of the world. So on this installation, we've got different types of fuses. These are 3 types of fuses we've got. These are what you commonly come across in many installations. This one is called, this is a Wylex rewireable fuse, BS3036. There's advantages and disadvantages of all of these. This has got many disadvantages actually. So in the inside, you're not going to be able to see that, but inside there's a strip of wire which connects both of these prongs. And you need to make sure that when you're rewiring them, when they blow, you put in the right size fuse. Because that's just a fuse wire. That's what's inside your regular fuse. Not very good. You need to make sure before you pull these out, you turn them off, because if you've got a loose bit of wire, you can easily touch that. And they're also not very accurate at tripping very well as some of the newer ones. This is another similar older type ones. This is BS3036. So it's a regular fuse, and this is the inside of it. So it's sort of a regular sort of fuse you find, similar to a plug top fuse. This is 15 amp 1361. Advantages and disadvantages. The advantage with this one over this one is it's easily identifiable what fuse you're putting in. So you can easily see that's 15 amp fuse going in. And again, it's not as accurate as some of the other fuses that we got. They've got a lower prospective fault current rating, lower KA value. So that's that one. And these come in various sizes. You've got 5, 15, 30, that sort of thing. This is a similar fuse to what you'd find nowadays, 60898. But this is the old version of 60898. So these fit into where the old 3036s fit in. It's better than the 3036, but it's not as good. It's only got a 3K rating on it on the side. You can see they're better than these, but they're not the best. This is similar to the ones that we fit now. So this is what you typically find in a consumer unit nowadays. This is 60898, similar to that, but these are a newer version, much more accurate. 6K rating, whereas this has only got a 3K. So these trip better than the old ones. These usually be backed up with an RCD. Can you remember what an RCD does, Kieran?
No.
Okay, so an RCD tests for earth leakage.
Yes.
Yeah, you get it now?
Yeah, but you don't... Oh, I can't remember what... There's a difference between how you explain it in college as well, because you say you're measuring the difference in between the neutral and the line, and that therefore would go through the earth, and that's why you don't say it's current going through the earth, because there should be no current going through the earth.
Yeah, typically there shouldn't be any current, as Kieran just said, there shouldn't be any current or amps going through the earth or CPC, but we know that there can be, especially on electronic equipment that's got a higher earth leakage. This is a pretty new one, Hager 30 milliamp type A RCD. These are similar to what we're fitting now as type A, and that offers just earth fault current protection. What protection does that offer, Kieran? 32 amp MCB 60898.
I don't know.
Okay, that's fine. This offers overcurrent protection. So if it goes over 32 amp, theoretically it should trip. So what's this, Kieran?
I don't know the difference between all of them.
Okay, that's fine.
I haven't learned it all yet.
No, you're learning.
I'm getting there.
You're not even started college yet, so you're still way ahead of everyone else. They haven't even got a clue. So this is called an RCBO, and what that will do is that provides the overload protection plus RCD protection in one. So this little thing here does the same as both of them put together. It does the earth leakage protection and it does the overcurrent protection. This, in this case, is a 32 amp MCB B rating, and it is 30 milliamps. You can just about see there. It's tiny. You're never going to pick it up on the screen. So these are typical MCBs and that you find on today's consumer units that you're inspecting. Okay, we've just identified all the circuits, written them all down painstakingly. A lot of them are off-peak supplies. So what do you guys do to test off-peak supplies? Do you put it down as limitation and not touch it? Or do you test them? Let me have your ideas. There's reasons why you would and wouldn't test them. If you think about it, off-peak, you don't have any control over when that will become live. So potentially you can be putting yourself at risk, which is why you should have also an isolator up front, but you know you never do. So you could put that down as limitation. Or do you do just the R2s and installation resistance test? What do? What I'm going to be doing today is Wonderlead R2 test and installation resistance on all the circuits. Because there's loads connected and I can't get to all the isolation points, I'm going to have to limit it to 250 volts. So we're going to go through the testing procedure as we normally would on a initial verification. You don't have to do that on the EICR, you can go in any order you want, but we'll just stick to the same method. So what we've got, the first test we're going to do is called continuity of protective conductors and continuity of bonding conductors. Right, so what we're going to use the R2 or Wonderlead method. First thing we're going to do is null our leads. So what we're doing is we're taking into account all the extra resistance provided by 50 meters of lead. It's going to be higher than if we had just leads just here. Put the clips, so the long bit, if you look at the long bit, you need to make sure that it's, so it's coming in here, it's going along this one there. And if you look between these two, there's a spring here. So what you want to do is make sure that this bit here is connected into that bit there, giving the least resistance. Okay. Going to null them. So we know that just these leads are 2 ohms worth of resistance. Now we've nulled them, we're getting 0 resistance. That's how we want it. Right, so with this we put this on our main earth bar, we get our probe, and this is where we do our R2 tests. Okay, that's all right. Testing things like cookers. 0.4. Yeah, that's fine. Fridges. I might not be able to get one of these. Does it need screws? No, not going to get in. We can't test these because it's not got any screws. What we usually do is connect it to one of the screws. That's good. Good. Washing machine. Yeah, good. Bonding conductor under here, which doesn't have a tag on it. Not a lot of room in here. We've got bonding conductor right there. Yeah, we've got good continuity. You've got break in this supplementary bonding conductor, if you can see there. It's a break. It doesn't have RCD protection, so we need to put that as a observation, and also there's no labels. And it is a metal incomer. Yep, good. Can't get any access to this cooker. Yep. Okay. This is not working, so we're not going to test that. Put that as a limitation. Metal light fitting. Possibly be off, but you never know. Yep, so that's good. Good. I didn't pick this up before. There's a crack in the ceiling rose cover. So I need to write that down as well. Just in here. Good. Not sure what that is. Yep. So we can't get access to this. Oh, I was going to say we can't get access to that because this is one of them, I think, the click fittings. So we can't get access to that because if we pull that out, it could damage the ceiling surround, the light surround. I bet you this cover hasn't been off since it's been installed. But rusted screws, terrible. We just check the tightness of these. Can't see any water coming in apart from around the bottom. It's not very good. And that's the R2 test complete. Next test we're completing will be the installation resistance test at 250 volts DC. We have to do it at 250 because there's a lot of loads we can't get to, like cupboards in the way, things like that. So we'll test at 250. Half 12, halfway through the day, having a little bit of lunch break now. What are you going for, Kieran?
Chicken and bacon.
How can I guess? Chicken. I've got a cheese and pickle, Mars drink, nice and healthy, and thank Crunchy it's Friday. What else you got?
Also got like 2K, 3 punches.
2K.
Healthy.
Better than Monster, isn't it? Anyway, we're eating.
Arguable.
Right, so next test we're going to do is installation resistance. Because we can't disconnect the cooker and hob, we'll do it at 250 volts with the load connection. What we've done is we've linked through the line and the neutral, so the neutral bar and the line for the circuit we're testing, and then the other end is on the earth bar, main earth terminal, just up there. So if you're testing at 250, you need to include all the earths, so you clip to the main earth as well. And we have, if you look at this as well, 22.5 megohms, which is fine. Minimum that we need is 1 megohm. And the reason we're doing this is if we get high enough megohms, insulation resistance test, then we know that we can put an RCD on it, it won't trip. To be fair, these don't look like they've been touched really, apart from the addition of a shower circuit here. So second one, just moved that along. See what I've done now, moved the crocodile clip along to the next circuit, so it's testing these cables now. 45.6 megohms, and keep moving it down. .9 megohms, next one. 44.1 megohms, move it to the next one. 41 megohms, and last one. 41.3. So we know that top DB, the main DB, is okay to have an RCD protection. It's got a good enough earth leakage that it won't become damaged. Next thing to do is ZE, which is earth fault loop impedance, external earth fault loop impedance. Can you remember that, Kieran?
No, I cannot.
Okay, that's fine. Need to uncover our main cover, covering up the earth, the line. Find our main earth, which looks like it's that one there. This one is hardly even done up, so hopefully that's the main earth. Clamp onto that, onto the main incoming earth. 2.53 ohms. Is that any good? No, is the right answer. Where it needs to be, we'll look at the main supply in a minute, but this might not actually be the ZE, the main earth. But if you can see it's got some black on it, you might have picked that up. This is the thickest cable, so it's a good bet that that is the main earth, but it might not be. With these Wylex boards, it's impossible to see behind some of these. It can be really hard to get them out. That is the thickest cable, it looks like, so it's a good bet that that is the main earth. So we'll do the ZE, let's have a look what we got. 0.19 ohms. So I've noticed something else on there. Can you see where that, you had burn marks before, it's totally burnt through where the holder should be right there. This is all turned off, so no damage in me hurting myself. So yeah, that's where it was, so that's not very good, is it? Something else I've just noticed, if you pull these conductors out, this is a socket circuit, ring final socket circuit. I don't know if you can pick that up, but the cables have got some oxidization on them. Not quite green goo, or is it? Need to keep an eye out for that. I think that's possibly heat damage from the next one along. Just damage that. Yeah, not quite green goo, but it's something to note. Cannot find. Ah, there they are. That's the ring final sockets. I hate these boards. There's no room to work in them. Impossible. I'm not going to test that yet. I'm going to not test that bit. We'll test that when we change the consumer unit. That is the probably not great, but being an EICR, actually you don't need to test it. As per NAPIT, that's what I said. Yeah, we need to test the figure of 8 ring continuity test, but the CPCs are twisted up, and it's right behind there. So we'll do that when we change the board over. Need to make a note of that. Another test we need to do is a Pfc test. What's Pfc, Kieran?
No idea.
Prospective fault current. Need to make sure we know how much fault current will travel through in the event of a fault. And we choose our protected devices accordingly. So it is 1.78 kiloamps. And this one, can you just press that button for us? Okay. Orange button. 2.49 kiloamps. So we're okay because we've got a 3 kiloamp system, but we're changing this out anyway. Okay. Whilst we're here, we check the polarity. To do that, we go between line and neutral, on a neutral first, and line. We've got voltage. Neutral to CPC, there's no voltage, as expected. CPC to line, we've got voltage. So we know polarity is good coming in. So we can tick the polarity box now. We're done with this now. What we need to do is put it back together and then inspect the outside incoming supply.
Cool.
So another test we're going to do is a ZS, which is the earth fault loop impedance. .44. We need to remember the highest one. 0.44. 0.35. Okay, that's cooker circuit, we'll do that last. Just doing a socket circuit. 1.32. .45. That's all working again now. Bedroom. .55. 0.55. It's still 0.55 is highest. .61. 0.72. 0.72 is the highest. Then I've got one more, don't we? Yeah, 0.72 is highest there. ZS a shower. ZS a shower, 0.13. isolate that. We'll take a look at the condition of the incoming supply. What are the bits of this then, Kieran? Can you tell me?
Well, you have the main fuse, which is there.
Yep.
The meter, which is there.
Yep.
And this, I do not know.
This is just a heating contactor. So what this is, I haven't seen one like this before, but this will control your off-peak, your storage heaters, that sort of thing. So that will control that. Because the line comes into there and then into there, so it will split. It will turn on the off-peak supply at some point. These cables are 25mm. Coming out of the Henry block, they're 16mm. So we're going to mark 16mm as the main conductors. That's going to be a 16 as well. How many amps is the main fuse?
Oh, this is 100 on the side.
It's 100 amps. Is it 100 amps?
No, am I wrong?
Well, no, this is the problem, right? It says 100 amps there.
Yep.
I can put money, loads of money. That's not 100 amp fuse because of the age of the building and all that sort of thing. I can put money. That's not 100 amp fuse. We're not allowed to break that to take a look because that doesn't belong to us. And they'll call the police. And they have been said that they can fine us so much money. Do you know what type of system this is? Earthing system. Well, what are the different types of earthing systems? Can you remember? We haven't really covered this too much.
Yeah, we covered it here and there, but I can't remember them.
Yeah. So there's 3 different types of earthing system. You've got TT, TNS, and TNCS. TT is where it goes straight to a earth rod. Where the main earth goes straight to the earth rod. TNS is where it's got a little tag off the bottom, the metal tag, and the earth goes straight to that. You've seen them before. This is, in this instance, the main earthing conductor goes into the side of the neutral block, which is under here. This is the line going through the fuse, and this is the neutral block. So the main earthing conductor goes into the side of the neutral block, and this is what we call TNCS, Terra Neutral Combined Separate. So it uses the neutral as an earth. That's it really. So that's TNCS. You need to recognise the system and you need to be able to draw it out, but you'll do that at college. Alright, what we're looking for here is it's all nice and solid. There's nothing to cause any alarm. It's all nice and they're solid. These are when they're good. No burn marks we can see. That's all good. So we're happy. We'll tick that off as good. So to summarise, it's all, not too bad condition, to be honest with you. To be fair, see a lot worse. You see some better, but this is not too bad. A few observations, but it's nothing that's too big a deal. Probably the biggest one is going to be the shower downlights, because a lot of this will be sorted out once we change the consumer unit over. But we'll issue what you need to do. If you're completing the EICR, you need to issue this with the observations. Even though you're going to change it, then you can do another EICR afterwards. It's just a case of deleting some of the things in there. And that's it really. Kieran, is 1:30 a good enough time for you to finish?
It's good, better time than any.
Should we go on to another job? Why you look so funny? Why you laugh at me? Why you laughing at me, brother?
Another job.
Yeah, we've got another. We can go to another job. Let's go finish off Shane Walk, shall we?
Not Shane Walk, of all places. Of all places, Shane Walk. It's a nice place. Just working there sucks.
You don't want it, does it? No, I don't want it. It's Friday, look, 1:30. I need to go and type this up properly on the computer anyway at home. It's just a lot easier. Bung loads of stuff in the book, stick it on the main computer when you get home. And then you can get out of it. You can do it at home with a nice cold beer if you want to. Okay, because Kieran don't want to work anymore, she's a lazy so-and-so, we better go home. Good idea?
Yeah.
Okay, he's happy. dock your wages. That's right. Right, so what we got left to say? Oh my God!
I forgot it.
Right,
Like.
we're going Shane Walk. No, we're going Shane Walk.
We're not going Shane Walk.
We're going Shane Walk.
I ain't going
Your
to Shane
fault.
Walk.
Your fault. Right, what we got left to say?
Like,
Comment,
share,
subscribe.